Here, guys, is a diagram shows a particle of mass 2 kilograms and 3 kilograms respectively, lying on a horizontal table in a straight line perpendicular to the edge of the table. They are connected by a taut, light, inextensible string. The second string passes over a fixed light pulley at the edge of the table, connects a 3 kilogram particle to another mass of 3 kilograms hanging freely under gravity. The contact between the particles in the table is rough with a coefficient of friction of 1/4. Okay, what I'm going to start off straight away is I'm going to just do the friction straight away. Okay, so 2G going downwards, 3G going downwards. R value, we'll call one of them R, and we'll call the other one N. Okay, so R equals 2G, N equals 3G. We can call it F1 and F2 for friction 1 and friction 2. What direction are friction 1 and friction 2 have to go in? Sorry? No, friction. It has to oppose the motion, so it's got to be to the left. Okay? So friction 1 and friction 2 have to oppose the acceleration, which means they're going to the left. One of them equals mu r, the other one equals mu n. Mu is a quarter, isn't it, in both cases? So our frictional forces are going to be it's going to be a quarter of 2g for F1, which is going to be g over 2 going to the left, and F2 is going to be a quarter of 3g, which is going to be 3g over 4, once again going to the left. Now, it says, show in separate diagrams the force acting on the particles when the system is released from rest. So what you got to do is you got to draw each one individually. Okay, so we'll start off with the 2 kilogram block. So, right here, 2 kilogram block, okay? Choose a letter for our tension. We'll go for T. So it gets T to the right. It's going F1 to the left. It has its weight going downwards, or its 2G going downwards. Its R value going upwards. And that's all there is, isn't it? Friction pulling it to the left, tension pulling it to the right, and its reaction force and its weight in balance. Okay. Then you have the 3 kilogram block. So once again, difference between the 3 kilogram block and the 2 kilogram block is that the 3 kilogram block has 2 tensions attached to it. So according to the 3 kilogram block, the T is working in the opposite direction, because when you're pulling something behind you, it's going to pull in the opposite direction. So your tension is pulling you to the left. Okay? It's called kinetic particles for a reason. It's called kinetic particles because the 3 kilogram block and the 2 kilogram block are connected via means of tension, nothing else. So the only force that affects it from the 2 kilogram particle is the tension. That's how they're connected, okay? Now, what also happens in the 3 kilogram block is F2, your friction working to the left against it. What also happens at the 3 kilogram block is the tension S working to the right, causing it to move right. It has an overall acceleration of A that goes to the right. Its N value is in complete balance with its 3G acting downwards. And that's your system there, okay? And finally, we have the 3 kilogram particle. We'll just call it the 3 kilogram particle as opposed to the 3 kilogram block. Now, the 3 kilogram particle has its 3G acting downwards, and what's going to act upwards, guys? S acting upwards, and that's it done. Okay. Now we're at the stage where we're going to try and make the 3 formulas. Okay. Yep, question?
Why in the 2 kg block is tension going the same way as the acceleration?
Okay, why is the tension going the same way as the acceleration for a 2 kilogram block? Because the full system as a whole, the full system is moving this direction here with common acceleration A. It's the only way it can go, otherwise it stays stationary.
What doesn't the tension usually go against it?
That was for gravity, where. But what we're trying to say here is that this one pulls this one. The 3 kilogram one is connected to 2 kilogram one, therefore pulls it to the right also. So tension is pulling it in the direction of acceleration. Okay. That actually also happened. I think what you're thinking was tension's always opposite weight, not opposite acceleration. Okay, because tension and acceleration, even in the gravity questions, are often in the same direction. Okay. So what we have here then, guys, is we're going to make our three equations. Okay, let's start off with the 3 kilogram particle. So 3 kilogram particle, we're going to have its overall, it's falling downwards, which means that its force is going downwards. Net force is acting downwards, so force equals MA. MA in this case is 3A. What else acts directly downwards? Its weight, which is 3G. Take away its tension going upwards. So 3A equals 3G minus S. Okay, no bothers there. Now we're going to go for the 2 kilogram block. So for the 2 kilogram block, what do you think we're going to do here? F, which is equal to MA, equals 2A. 2A is going to the right. What other force is dragging it to the right? Look in this picture here. What force drags it to the right? T drags it to the right. What brings it to the left? F1. We also determined that F1 is G over 2. I'm not the biggest fan of fractions, so I'm going to get rid of them immediately. 4A equals 2T minus G. Okay. Now we're on the 3 kilogram block, which I'll do in red. Now your 3 kilogram block is going to be mass by acceleration, which is going to be what, guys? 3A. 3A going in which direction? Going to the right. Start off with any forces that bring it to the right. So what force brings it to the right? S. Anything opposing it? T. And anything else? F2. And we said F2 earlier was 3 over 4. 3G over 4. Once again, fractions aren't going to carry with me here, so we got to get rid of them. Multiply by 4. 12A 4S minus 4T minus 3G. Isolate your three equations. So I'm working off there, okay? Everything else doesn't matter now. So, let's make a decision. Tough decision. Okay, I have an idea, right? My idea is to isolate 4T. Now, the reason why I'm going to isolate 4T is 4T is exactly double of 2T. It means I won't have to deal with any fractions, okay? So I'm going to isolate 4T, and then I'm going to multiply that second equation by 2 to make sure I have a 4T handy, okay? Don't have to deal with any fractions today. So I'm going to turn the first equation into 8A equals 4T minus G. Then I'm going to turn this equation here by bringing 4T to the left. 4T equals 4S minus 3G. What do you say? Multiply this one by 2, so that is 2G. Thank you. So I'm going to, that's going to be 4T equals 4S minus 3G, and then take away your 12A. I now have a direct substitution for this 4T here. So 8A equals 4S minus 3G minus 12A. minus 2g, right? So 20a equals 4s minus 5g. I haven't used this equation at all, have I? Reread the question. Just wants me to find the common acceleration first. Means isolate a. So I have 3a equals 3g minus s. I want this to be 4s, so I'm going to multiply everything by 4. I'm going to get 12a. I'm going to get 12g minus 4s. I'm going to add directly downwards. 32a equals 12g minus 5g. 7g. A equals 7 over 32g. Okay, once I get that, I have to find the tension in each string. To find the tension in each string, I'm just going to do it this way, okay? So, using this equation here, we're going to say, this equation here, I'm going to say that 2t equals 2t equals minus g.
No, not P plus G.
Sorry?
Not plus G.
Oh yeah. I'm getting it wrong. It's going to be 4a plus g, isn't it? There you go. Thank you. Now, t therefore is equal to 4. It's equal to 4a plus g over 2. That's an a, by the way. But while I'm here, I might as well turn it into 7 over 32g. So if somebody do me the multiply 4 by 7 over 32. Pretty sure you get 7/8. Add it to 1 and then divide it by 2. I'm thinking of
15 over 16G.
15 over 16g. Perfect, thank you. And then we're going to find out what S is using a similar system. S equals, bring S out the other side, equals 3g minus 3a. So if somebody can do S equals 3g minus 3 times 7 over 32g. Call out what you get there.
Yeah, 75 over 32G.
Okay. Okay. Is that what we expected? Let's find out. Well, S is the bigger tension because this guy here is hanging freely. Okay? And then the second tension is like a secondary force that you only need to drag an object across the table as opposed to actually completely lift an object up. So that explains the discrepancy between the S value and the T value, that the S value is much bigger than the T value. So even if the coefficient of friction was 1, in general, lifting the object against gravity is much harder than taking an object across the table with friction. Okay, so it's consistent. So that was question. What was that? Question 10. Okay.